Okay, take your compass and put the point at A. Now, if you haven't yet, go ahead and label your triangle ABC. And open it up so that it just is barely below the line. You don't want to go very far below the line, just a little bit.
Oh.
So it's just like mine. So now we're just going to do a little pendulum swing to mark off 2 points on the line. So basically we just created 2 intersections.
Are we doing this with a color pencil?
One is right here, and one is right
Mine goes
here.
off the line, so.
Are we using color pencil? I think that one.
I would use a colored pencil so you can kind of keep track of the colors, okay? Now, what we're going to do, basically this is our above, arc, and below. Remember that? Arc above, arc down
Oh my
below.
gosh, I need a new paper.
But if we go above, it's just going to be through point A. So it doesn't really matter. So we're just going to go below because that's the reflection of point A. So put a little X down below. Flip it the other way.
Do we leave the same thing?
I need a new paper.
And then do another arc down below. So basically we're just doing arc down below, and that creates a little X. What are we going to label that X? A
A prime.
prime. That is the reflection of point A. Now this time when you line up your compass with point C, you're going to have to move the width a little bit because C is closer to the line. So move your width, move your pencil hold so it's just barely below the line again, and then you're going to do another pendulum swing. This is where you can kind of see it's helpful to use different colors so your arcs don't, some of the arcs get kind of close together. And that basically just created 2 new intersections, one right there and one right there.
Oh, something just fell off the
Shouldn't go
wall.
off the page if your pencil's just
But it
below
goes
the line.
Look.
And now we do, from one of those holes, or one of those points, we're going to do an arc down below.
Oh no.
Switch the other way. Do an arc down below. That creates a little X marks the spot. That is C prime.
Oh my god. But I'm just doing C right now,
I
but
haven't
it's going
even
all
done
over
it.
the place.
So now you're going to place your point at B. Place your point at B. And then for the third time, I'm going to tell you, only open up your compass so that it's a little bit below. By a little bit, I mean like a centimeter. Just a little bit below the line. Do your last pendulum. That just created 2 new intersections. So with your compass, you're going to do an arc down below from one side. You're going to do an arc down below from the other side.
You're so smart.
That makes our last X marks the spot. We'll call that B prime.
I don't understand what's wrong with it.
Now this is the cool part here. If you did a really good job, and you take a straight edge to connect your 3 points, it should be the exact same triangle, the exact same size, reflected over the black line. So mine came out pretty good.
Good job, Mr. Stutz.
Looks good. Alright, so today for rotations, we're going to start with a little video, yeah.
Holding one corner of a rectangular sign, what's going to happen? The sign swings down. It has a rotation around the tack, but geometrically, it's the same shape. Rotation is really common. The triangles that make up spokes on this bike wheel are rotating around the center axle. Mathematicians use rotation to describe shapes on a coordinate plane too. Check out this triangle. In mathematical language, we'd show it like this, which describes the points of the triangle's vertices based on where they're located on the coordinate plane. To rotate an object, you first need to choose the center of rotation. This is the point that you'll rotate the object around. To make it easy, we'll choose point 0, 0, or the origin, on this coordinate plane. When we rotate the shape, we need to keep the shape exactly the same distance or equidistant from the center of rotation all the way around. If we rotate the triangle 1/4 turn around the point of origin, counterclockwise, keeping the point of rotation exactly the same, then the triangle moves to a different place on the coordinate plane. The triangle shape stays the same, but the triangle has rotated, and the points used to describe the triangle have also changed. To show that a triangle has rotated, we use a little symbol like this. So now we have turned a geometric shape around a point. That's what rotation means. We can use it to move shapes and describe their movement.
Number 1, we have to match it to A, B, or C just by looking at it. How many degrees did it turn? 90. So 1 would be B. This is super easy. What about number 2?
Third.
Yeah, it would be A, and obviously 3 looks pretty obtuse. It's a pretty good guess to say 150 degrees there. Just a reminder, I told you this that very first day, but you might write this down. It's always going to be counterclockwise unless if I tell you otherwise. So if they just say, rotate this 90 degrees, we're automatically going to assume it's to the left or counterclockwise. Okay? Now sometimes they will say clockwise, but if they don't specify, it's always assumed counterclockwise. Okay, so let's take a look at your little cheat sheet here. Now they use A's and B's, yours is X's and Y's, but go ahead and on your cheat sheet, locate the rotation section and find rotate 90 degrees. What does it tell me to do to all of the points X, Y? Switch it backwards and make the Y value negative. So this would be negative BA. Same thing, they just use A's and B's instead of X's and Y's. But you're going to switch the order, and the number in back is going to come to the front and be opposite. If it's negative, it's going to be positive, or if it's positive, it's going to be negative. Okay, now look at 180 degrees. To rotate something 180 degrees, what's going to happen to the point XY? That's it. They both become negative. Did the order change? No, it's still XY, but it's negative X, negative Y. So we'll write that as negative A, negative B on here.
Say one's already negative, so positive or
Correct. Negative, negative makes it positive. And then the last one is 270 degrees. XY turns into Y, negative X, which in this case we'll call B, negative A. Now, real quick, counterclockwise 270 degrees. What's another way that I could ask that? Clockwise 90, right? If I ask you to go clockwise 90 degrees, that's the same thing. So if they ever ask you clockwise 90, look at the rule that's counterclockwise 270. Does that make sense? Okay, cool. So let's practice one of these. So take a look at this first example here. And the first thing I always want you to do is write down the rule so you can really focus on that rule. So this one says we're going to rotate 180 degrees about the origin or around the origin. So if you look at your little cheat sheet, these are always about the origin, these 4 cheat sheets here. So what is our rule for 180? We need to take X, Y, and do what to it?
negative.
Make them both opposite. So negative X, negative Y. So I'll give you a second. Go ahead and plot J, K, L on your graph and make sure you label J, K, and L. Now let's do our rule. So we need to take each point and make them both opposite. So if I start with 2, 2, what do I need to do to both of those values? Make them both opposite of what they are. So J prime is going to be negative 2, negative 2. Letter K is going to be opposite, opposite. So if it's positive, it's going to be negative, and if it's negative, it's going to turn positive. And then the last one, letter L, would be negative, negative, so positive 1, negative 6. Now, plot your new points and make sure you label them with the J prime, K prime, and L prime. So here is what your final answer should look like. Now, what does this look really close to if you're not careful? If you just glance at it, you might say this.
Wait, what?
It kind of looks like a reflection over whatever line this is, right?
Hold on.
But how do we know it's not? It's definitely not a reflection. There's kind of two things that show me. Veronica, what's one of the things?
Because now the K's at the top.
Yeah, can you see how L is now K prime? If it was a reflection, that'll be L prime. And there's another way that I can kind of tell. See how this is kind of the shorter of these two sides? So the shorter side is down here, and then the shorter side is up here. So it kind of flip-flops. So it definitely could not be a reflection. It rotated around. Okay? So this time, let's write the rule out together, and then I'm going to give you a second to do it on your own. So how far are we rotating it this time? 90 degrees, and it's always considered to be about the origin, unless if I tell you otherwise. What is the rule to rotate 90 degrees? Negative yx. Write that at the top. Write down your rule so you can look at it and do the operations. So now take every point xy, turn them into negative yx, and then plot those points and see what happens. So here's your 3 points. Now I'm going to plot negative 2, 2 is j prime. Over 5 up 4 is my k prime, and then L will be negative 6 up 1. Uh-oh,
Like a straight line.
what did I do wrong?
Go down -1.
Oh, sorry,
Uh-oh.
positive 1. Mr. Starks. So negative 6, negative 1 is L prime, and then connect them. And there's your final answer. So this one's only 90 degrees. One way to check if you're right, I showed you this last class, it's kind of handy. If you take a line and connect it from the origin to its image, it'll create the angle of reflection, or of rotation, sorry. So if I go from L to the origin to L prime, what do you notice? What angle is that? The right angle. If you go from J to the origin to J prime, that's a right angle again. And then the last one, K to the origin to K prime, is a right angle. All right.